Composition of blood. It is of two part. You have two part, that is the liquid part, also known as plasma, and you have the cellular part known as three types, that is RBCs, WBCs and platelets. So let us start with the liquid part, plasma. Important characteristics: it is pale yellow in color, contains inorganic minerals dissolved in it, and it also contains clotting factor. And the clotting factor, the element that is present is fibrinogen. Many times you must have noticed that there is a difference, it comes in ICC also, difference between plasma versus serum. Okay, serum. So plasma, the definition is given on top. The serum, only one difference is there. It is a liquid part which contains all the inorganic minerals except for the clotting part. The means the element fibrinogen is not there. Alright, so let's start with the cellular part. First we'll start with RBCs, red blood cells, but every time it's been asked in the question, erythrocytes. Alright, another name for RBC is erythrocytes. Let us understand why it is, understand the shape and why it lacks nucleus and mitochondria. It's biconcave in shape. The reason is to transport maximum oxygen. It has lack of nucleus and mitochondria. If there's a nucleus, the surface area will be less, and mitochondria means energy. So most of the energy, that is the oxygen, will be utilized. So for that reason, there is absence of nucleus and mitochondria. So it has lack of nucleus and mitochondria, so that to increase the surface area and to avoid the use of oxygen. RBCs, they have nucleus in the beginning, but when they start the process of transportation, that is the nucleus degenerates. All right, when they start the process of transportation, the nucleus degenerates. So RBC has presence of pigment that is known as hemoglobin. Hemo means iron and globin means protein. This pigment has the affinity to attach oxygen, carbon dioxide and carbon monoxide molecules. Now let us understand, let us take this over here. First, if I am there in a room and there is like oxygen and carbon dioxide over there, so what will this hemoglobin do is, the hemoglobin has the affinity of attaching itself to oxygen first, and in the end remaining hemoglobin will attach itself to carbon dioxide. So it has affinity for oxygen, so it attaches first, remaining hemoglobin will attach CO2. Now when there is too much of let's say I'm stuck in a room with carbon monoxide, okay, there's presence in a room and there's less oxygen. So what will happen, the hemoglobin will be having higher affinity for carbon dioxide, so it will start attaching carbon monoxide. So what will happen, this will result in poisoning, carbon monoxide poisoning. Okay, so when hemoglobin attaches itself with carbon monoxide, we have carboxyhemoglobin. Few important points of RBC. So important features are, I said. Now where is it present? It is present in bone marrow, and in case when it's in embryo, it is present in liver or spleen. The lifespan is for 120 days. And where it gets destroyed? It gets destroyed in liver or in spleen or in bone marrow. Very important, this counts for one marker in ICC. Abnormal increase in RBC is known as polycythemia. Abnormal decrease in RBC is known as erythropenia. Right? So in the next class we will do WBCs.